Hi guys, let's do section 1 of chapter 11. It's going to be about Gregor Mendel. Pretty smart dude, one of my favorite scientists. So, in Mendel's time, scientists thought, and just people in general, thought that traits became more similar over time. It was called the blending concept of inheritance. Parents of contrast in appearance produce offspring of intermediate appearance. Okay, so it'd be like mixing red Play-Doh with blue Play-Doh and getting purple. That's what they thought traits were like in people. Hair color, eye color. If this was true, eventually we would all have all the same hair, all the same eyes. I mean, everything about us would get more and more alike until we were identical. Okay? Mendel, however, decided that that was wrong. Okay? And he figured that out through years and years of study. He formulated the particulate theory of inheritance. He also proposed the laws of segregation and independent assortment, which we're going to talk about in more detail later on this chapter. Inheritance involves reshuffling of genes from generation to generation, making them all a little bit different, making some people tall, some people short, making our hair different color, but we don't get more and more alike as the generations go on. So this reshuffling is why we all look slightly different. So who was Gregor Mendel? Well, he was an Austrian monk. He studied science and mathematics at the University of Vienna, and he conducted breeding experiments on garden peas. He carefully gathered and documented mathematical data from his experiments, and this data is what led him to believe the two laws that we proposed on the previous slide, the law of segregation and independent assortment. He is the one who formulated those early laws. He had absolutely no knowledge of cells or chromosomes. He didn't even have a microscope. Okay, and he did experiments on the inheritance of simple traits in the garden peas that he studied. And he disproved the blending hypothesis. He was like, you know what, guys, this doesn't make a whole lot of sense. So let's try to find something that does. So here is a painting of Gregor Mendel holding a pea plant, and then a photograph of a pea plant, which was the plant that he studied. So the garden pea was the organism that Mendel experimented with, and it was a good choice for a lot of different reasons. It was very easy to grow. It had a short generation, so it didn't take long from seed to mature plant. And it is normally self-pollinating, but it can be cross-pollinated by hand, which we're going to talk about in just a minute. Pollen was transferred from the male anther of one plant to the female stigma of another. Okay, and true breeding varieties are available, which we're going to get to in a little bit, and there are very simple, objective traits to study. So you can easily observe the trait just with your eyeballs. There's no real process to it. I can look at a pea plant and say, yep, that one's got a purple flower, and that's what it took. So here we have garden pea anatomy. We have the anther, which is this yellow bit here. It's attached to a filament. Okay, and together they make up the stamen. The female parts are a little bit more complex. They consist of the stigma, the style, and the ovary or ovules, and they make up the structure called the carpel. So to ensure that the pea plants were pollinated the way that Mendel wanted, he would actually cut away the anthers. He would cut away the male parts with the pollen, and he would use a paintbrush to bring pollen from one pea plant to another. Alright, so we're going to end there on this video, guys, because I don't think I'll have enough time to get section 2 in this one. So, that's it. If you have any questions, let me know.